Hey guys, this is Kyle, and today's video is on modeling lab data.
So today let's talk about modeling lab data. Often we want to analyze, graph, interpolate, extrapolate relationships in lab data. Let's see how to do this with your calculator. So in this simple example, we're going to look at the data that's on the left-hand side, the X and Y columns you see there, and we'll use a TI-84 calculator to do it. So let's get our TI-84 calculators ready and see if we can keep going along with the example that we see here. So let me get out my calculator. We're going to start with the stat and then edit commands. Enter the X and Y data points into L1 and L2 respectively. If you have data in there already, just click on the top of each lesson, press clear, then enter. Please don't press delete, but rather press clear and enter. So here we are. We'll put the data into L1 and L2. Just type in the values and try not to make any mistakes. You can always fix them if you do. So there's our data in L1, and here's our data going into L2. I did make a mistake there on the 90, but we got it resolved. And we'll just keep on typing all the data in and just check and make sure you've got it correct. So there it is. Now we're going to calculate a straight line of best fit through the data and store the equation of that line of best fit in the function y1, so you can graph it along with the data. Let's see how to do that. Here we'll go to Stat, we'll press Calculate, and then we'll go down and choose option number 4, which is linear regression. We want a straight line through this data point. So we'll get the X values in L1, the Y values in L2, just like they came up. We'll press down a couple times here, and we'll store the equation in a variable. Press Variables, Y variables, choose a function, and I'll store that in Y1, because I want that equation stored in Y1, so later I can do it down, calculate, and away we go. So press calculate here, and there comes the equation. That's our straight line of best fit through the data. Let's go have a look at it in the functions Y1 section. Press functions, Y equal, and there it is. Make sure you turn on both the plot and Y1 active. They've got to be black. We want to see both of them being graphed. Okay, so here it is. We'll press zoom, press 9 for zoom stat, and we'll zoom right in on our data. So there's our function, our line of best fit, and our data. I'll just notice that the Y values are in the vertical column and the X value, or the Y values are vertical and the X values are horizontal, as you would expect. Listen, if you're alert, you probably recognize this is the degree Celsius and degree Fahrenheit relationship. You have Celsius being X, Fahrenheit being Y, and there's that expression you probably know already that Fahrenheit is 1.8 Celsius plus 32. Okay, so that's what these two values represent. Of course, real data probably has some noise in it, not so straight line as this, but certainly would try to learn here, okay? So this relationship can now be used to interpolate, which is to calculate between, and extrapolate, to calculate outside points in and out of our data set here, okay? Of course, okay, you don't need to go through all this shebang to calculate degrees Celsius and Fahrenheit conversions. You just can do it using algebra. But let's learn it here in what I'm going to call the shallow end of the pool before we get into the deeper water with data that's not quite so nice and clean. And we'll calculate some other values of Y or degrees Fahrenheit based on different values of X or degrees Celsius using our data model, the one that we just modeled in our calculator. So first thing is just Y is equal to 1.8x plus 32, and just use values in your algebraic skills. Just substitute some values in there and you can get what you need. Or let's see how to do it with your calculator. We're going to use that function y1 we defined and calculate values. So press calc and then value. Here we go. We'll press calculate and then value. So we can just type in here various x values. So imagining we wanted to find the value on the y-axis when x is 12. We just press 12, press enter. There it is. You see y is equal to 53 point whatever it is under there. And you can press other numbers, say 28, and get y is equal to 82 point something. You can come up with 52 or really any other numbers that you like as long as they're inside your data here. See 68, various other numbers that you like. Okay, so this is calculate value. If you want to get a value of say -4 for x, you can see that y is 24.8 down there. It's pretty straightforward, just calculating numbers based on that straight line regression of 1.8x plus 32 that we got before. Okay, so that's the first idea. Use calculate and then value. Now we're going to use the data table function on your TI-84 and generate a list of values for y based on x all at once. So we'll just go here, press table. Okay, it's on the graph, and you can see here a table of values. You can scroll up and scroll down on this table and find all sorts of different values for y based on x. Okay, so that's the idea of table, and then of course make sure that you have a look there and scroll up and down to find various values for y based on x. Remember, if you want to calculate values outside your data and extrapolating, you'll need to adjust your viewing window, not in table but in the calculate value part. So let's see how to do that. Say for example, just press the window button, and I'll expand my window here away from a -10 as the minimum value for x here to some other much smaller value. So maybe -100, perhaps a larger value, or more negative anyway, huh? And we'll just go down here and adjust the y values as well. We'll change the minimum y value here to, say, what shall we use? How about we'll use -65, and then the maximum y value we'll just leave alone. And you can see the window is different now, and we can extrapolate values outside of our data in this manner. If you want to calculate values outside, just make sure your window includes the point you're trying to calculate. Okay, so that's about it for simple data modeling or regression analysis. Try to have a look at the next video, Modeling Lab Data Part 2, for more, and we'll get into noisier data sets, modeling assumptions, and really quite a bit more. So anyway, stay tuned. Modeling Lab Data Part 2.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe.